Let's talk about optimization. What exactly does that mean? I made this little frame here to demonstrate some concepts of optimization. Optimization is the process by which you convert ordinary vector art, which is just simply numerical data, into something that's actually appropriate to be displayed by laser scanners, which of course laser scanners are velocity sensitive. You can't overdrive them. They simply won't work, and you might even damage them if you do. So in this image right here, I'll show you what we have. Okay. All right. Yeah, okay. So now we can see the vertices and we can see the blanking path. This is the 0th vertex. This is where the image actually starts. There's vertex index 1, 2, then there's a blank vector to 3, and then from 3 to 4 is again a lit vector. Okay. So if we go into menu H, this menu is all about things that you can do to the data in the current frame that's in the display or the entire frame set. The difference is the current frame, you just simply use the key as it is listed, and to affect the entire frame set, you use the shift key and hit the key, and it'll do it to the whole frame set. Okay. So as you can see, things are broken down here pretty good. You can do a lot of individual things. So the first thing I'm going to do is I'm going to hit S to add lit distance span. So I tap the S key, and let's turn the indexes off so you can see things. Okay, and you can see when I did that, it added a whole bunch of points along these lit vectors, right? But it didn't do anything with the blank vector because we just said add the lit span to the lit vectors, so that's what it did. These points here now are going to control the velocity of the scanners because the DAC, that's the clock, it has a clock that's going to clock out these samples one after another. And if this was being prepared for a sound card DAC, and your sound card wave file, if you're going to make a wave file that's 48 kilohertz sample rate, this would be the position of the scanners every 48,000th of a second. And it's based upon what you find in the tab menu here. We have option 3. Maximum optimized lit vector in points is currently set to 800, and the maximum optimized blank vector in points is set to 1,000. And these numbers here are relative to the coordinate space that we're in, which again is signed short integer space. There are 65,536 point locations along all of the cardinal axes. And so the distance between this point and this point is going to be no more than 800. LaserBoy calculates the length of this whole vector, and then it figures out an integer number of divisions of that vector to divide it into such that each vector is no more than 800 points along this line, and then it places all those points collinear on this vector. So another thing you can do, okay, in the menu H, of course, is you can also control the blank span, which is, let's see, S is the lit blank, and T is the add to blank span. So if we hit T, you can see it just added these same concept here along the blanking path. And the reason they're separated is because maybe you want your lit vectors to have a certain density to them, meaning the longer it takes for the laser to draw across this line, you're gonna, that's more photons. It means the line will be brighter. If it's ripping across here really fast, it's not going to be quite as bright. So you can actually control the density or the intensity of the laser, along with saving your scanners, but because of the velocity situation. And you might want to treat the blanking a little bit differently because the laser's turned off, so you don't have to worry about the density of the line. You just want to get from here to here as safely as possible for your scanners. So that's why those are managed separately. So, okay, not only does LaserBoy know how to add the points along these lines, but it also knows how to get rid of them. It knows how to find collinear points and eliminate them. And it does this in the tab menu, you see this insignificant angle in degrees. This is option number 1. Currently it's set to 1 degree. What that means is it looks at the angle from this point going into this point and then this point going into this point. And if that angle is less than or equal to 1 degree, it considers that to be these points to be collinear. So it just keeps looking at the angle, the entry and the exit of every one of these vertices to determine whether or not that angle is greater than or less than whatever this setting is, which is currently 1 degree. And if it is less than 1 degree, also it has to be the same color, because, you know, if these were all different colors, you wouldn't want to eliminate that. You'd have to keep that information. So as long as the points, as long as all of the vertices along this line form, or all these vectors are the same color and they're all collinear within 1 degree or less, LaserBoy knows how to find them and eliminate them. And that basically looks like you've got remove, where is it? Remove, reduce lit vectors is J. So we hit J and see, they're gone. We're back to what we started with as far as that goes, right? So now you don't have those anymore. We're back to our original stripped down simple vector drawing. Another thing that you can do, or that LaserBoy does, is it puts dwell in the angles. The reason I drew this image the way I did, here's a nice rather sharp angle, okay? If I say add angle dwell, which is R, I tap the R key, you can't really see anything here because of the view that we're looking straight into space, but we're going to go ahead and hit G, so now we can see the vector order in space. And if I rotate this around, you can see it added all of these points in this corner and also in this corner and also here in this corner. And the reason it did that is because the line is going to, the laser is going to scan into this sharp angle here, and it's going to sit there until it settles down to an absolute stop, and then it's going to go ripping off into another direction. So this, it maintains the sharpness or the crispness of this angle, same as with this angle and with this angle. And it does that based upon the degree of the angle, right? So if you go into the settings menu, you can see here there's a setting, maximum dwell in microseconds. Currently it's 333 microseconds. Now, this is one of the only, this is one of those situations where this is a time, microseconds is related to time, okay? And microseconds here is going to be relative to our output sample rate, the wave sample rate, which is currently set to 48 kilohertz. So 333 microseconds works out to however many samples that is at 48,000 samples per second. So each sample is a 48,000th of a second. How many does it take to come up with, to make up 333 microseconds is what determines how long this is, how many points you get here, how long it dwells in a corner. And the reason that it says maximum dwell in microseconds is the maximum dwell that you're going to need is for a full-on reversal of direction. This is close, right? So if the laser was scanning across here and then doubled right back onto itself, that's a 180-degree turnaround. In other words, you're heading this direction and then you're heading right back again. So the maximum angle that you can possibly have is 180 degrees total turnaround. So that's where you're going to get your most dwell. As a matter of fact, I even have a frame that demonstrates that concept of the severity. There it is, the severity of the angle. Okay, now this is in fact a two-dimensional frame, but if you rotate it with vector order being shown, you can see, okay, if you look straight on, there's no angle, there's a little bit of an angle, a little bit more, and so on, all the way down to where it's a complete fold back onto itself, right? So if I go into menu H and I hit R here, and then I rotate it, you can see that it's adding almost none. Here, I'll shrink this down a little so you can see it. Okay, Here it's adding none, a little bit more, and so on, until all the way down to here. This is your total turnaround. This is going to be the most dwell that you're going to need in order to do that total turnaround. So that's why this frame exists, is to demonstrate how the dwell changes based upon the acuteness of the angle. Okay? So in combination, you can control all these things, right? So in combination of things, going to menu H, if you minimize, that basically strips out everything. Any kind of added vertices that are for the purpose of controlling the velocity of the scanners are stripped out. They're gone. And then if you optimize with W, it adds everything all together. It does the lit distance span, it does the blanking distance span, and it does the angle dwell. It also controls, I'll show you something else here. Let's go back to a frame like. Okay, there's a good example. All right, so in menu H, we can randomize the order. See, this randomized segments. If we hit P, see now they're all jumbled up. They're all randomized, okay? This would be a terrible order in which to scan these things, because you start here and there and you jump all the way across and whatever. That's not good. So one of the things that also part of optimization is finding the shortest path between all of these lit segments. And you can do that also as an individual incremental step, and that would be reorder the segments. So if I hit Q, there, it just found the shortest path now to traverse all of these lit segments. So when you optimize something, it does a combination of these things so that you end up with the shortest path, you end up with lit span and blank span along the vertices, and you end up with angle dwell in all of the corners. And again, all of these things can be controlled with these settings. The insignificant distance in points is how, well, actually that's a tricky one. We'll get to that one. Insignificant angle in degrees determines whether or not vectors that are all the same color are in fact collinear, so that they can be removed in the minimize process. And then the maximum optimized lit vector in points determines how a straight line is divided into subvectors, collinear subvectors, to control the velocity of the scanners. Same applies to the maximum optimized blank vector, except that it applies to blanking path. And then you get your maximum dwell in microseconds, which determines how long it dwells in the corners. So that's what optimization is about, sort of, in a nutshell. There's other reasons why you might want to add a lot of points to a frame just for the sake of having, here, okay, we'll go to menu L and we'll select it and we'll make it as big as it gets. Okay, now let's just go there. Okay, so if I go into menu G and I change the palette to something else. Now, if I want to recolor this and I want to span the palette, recolor palette span factor, set it to 1, enter, okay, escape, no, okay. Now, this used to have the default Ilda palette. I did a best match to color to this new palette here, so now this frame is using this palette. If I want to use this palette to recolor this frame in some way, let's say we're going to span across the x-axis with the palette, it looks like this, okay? Basically now the palette starts here and it spans across the space to here one time. You see how you get this strange artifact, these weird things? That's because you can only color a vector, right? So this whole vector can only be one color because the vector really is, it's designated only by the location of this vertex and the location of this vertex, and it's the line segment that connects the two. So if you don't want that weird artifact going on there, you might want to go into menu H, hit S, and add more points based upon this factor maximum optimized lit vector in points. And then when you go to recolor it, you got more points to hang your colors on. So if I say 1, it looks a lot more smooth because each vector is a little bit smaller, so you get more color, you get more resolution of color, so to speak. So that's another reason why you might want to add more points to something, is because the only way to add color to something is you have to color a vector. And so more vectors means you got more opportunities to add colors to your frame. So that's kind of what optimization is about, and it's also a reason why you might want to add points to a frame in order to be able to have better control over how it's colored.